In this session, we are going to study the electric circuit and the types of electrical elements which is used to develop the electric circuit. The electric circuit is a closed path or the interconnection of the electrical elements linked together in a closed path so that electric current can flow continuously. Now here, to form the electric circuit, we need the electrical elements. In this figure, we have battery and then we have resistor. The battery and resistor are connected by the conductor this way. Now this battery and resistor are called the electrical elements, or in this circuit, we also call it as a branch. Now when the battery and resistor are connected together, it forms the closed path. When there's a closed path circuit, when there's a closed path, current can flow through this, so we call it as a electric circuit. Now these are the elements of the circuit. We have diode, capacitor, inductor, resistor, then we have sources and gates, and then we have so many types of electric the circuit elements. Now let's see one by one. The first one is resistor. This is the image of the resistor, and in the in the circuit elements, we have two types of elements: the passive and the active. This resistor falls under passive elements, and these two are the electronic symbols of the resistor. You can use either of these two. Okay, let's define what's meant by resistance. Now, it's the physical property of an element that opposes the flow of current. The unit of the resistance is ohm, and the ability of our material to resist the flow of current is called the resistivity, and the unit is ohm meter. Now if you compare the resistivity of the two material, copper and the glass, we know that copper is a good conductor and glass is an insulator. So if you compare the resistivity of these two material, you will find glass has a higher resistivity than the copper, which means glass can opposes more, like glass can oppose current flow more than the copper. Again, here we have example, or is being explained with this two water tank. In the first water tank, it's connected with the pipe without internal resistance, and then for this one, it's connected with the pipe is connected. The pipe has an internal resistance. If you compare the flow of water here, the water flow will be smooth. Here, water flow is opposing by this resistance. So this nature you can compare it with the our actual resistance. Our actual resistance also behave similar to this, same as this. Okay, let's see the value, how to calculate the value of the resistor. Now to calculate the value of the resistor, we should know the color codes or the color bands. In this table, it gives the color coding of the resistor. You should know the sequence here. We have first, it's starting with the black, brown, red, orange, and so on. And here, to calculate the value of the resistor, we have to check the position of the color. In this four band code or the four color code, if you consider this one, we have green, blue, yellow, and then we have gold. For this number of band in four band code, first two band can be taken as a value, and then third one as a multiplier, and the fourth one as a tolerance. Now that tolerance is to calculate the percentage of error in that value. For example, if it's 1 kilo ohms, then for the 1 kilo ohm resistor, if you measure if you measure practically, you will not have that 1 kilo ohm. You will have either 998 or 900, or sometimes more than that, sometimes less than that, but it should be within certain percentage, or there should be tolerance, certain limits. That's called the tolerance. And for this one is green. So green, if you see here, is in the first line, so is 5. And again, second one is blue, is 6. We have 5, 6, and then we have yellow. It's a multiplier. Now next time the third code we have to okay, sorry, I got lost in between. Okay, we are discussing about the value of the resistor in for the 4 band code. Now, first two, we have to consider it as a value, third one as a multiplier, and then the fourth one as a tolerance. And if there's more than four, like here, another example is five band code, five color code. So first three will be considered as the value of the resistor, and then the fourth one will be the multiplier of the that resistor. So, and then the fifth one will be the tolerance. Now in this case we have red, then we have orange, then violet, black, and then we have gold. Now this gold is not gold, it's brown. The tolerance level for the brown is plus or minus 1%, and then for the red is 2. Okay, let's consider let's calculate the value for this one. 2, then we have 3, and then we have 7 times the multiplier black is times 1, which means 237 ohms with plus or minus 1%. Now for this 5 color code, and for this one 4 color code we have 7. I mean we have green is 5. We have black, we have blue with 6, 5, 6 times 10,000. So is 560 kilo ohms for this one with the plus or minus 5% tolerance. This is how you should be calculating the value of the resistor. Okay, here you have this small classwork. You can try it yourself to find the R value for the following sets of the color coding. And then with this again, you can try to do the homework, the series and parallel connection of the resistor. And once you know the series and parallel connection behavior of the resistor, then you will also understand the brightness of the lamp connected in series and the parallel. You can try to look into this too. Okay, in the next session, we're going to discuss about the capacitor and the inductor.